So a little explanation on a heat recovery system or a heat pump on these larger VRFs that have multiple air handlers on one condensing unit. So here's our situation. This is where I see guys with 10, 20, 30, 40 years of experience making mistakes, especially if they're the beer can cool kind of guy. So we are maintaining the temperature in this room that has a massive heat load inside of it. But right now it's doing all its job. Just a minute ago, this system was off. Both compressors were at 0. Right now you can see this one's running 56 Hertz right now. And this one has 2 compressors, but they're both doing just below, you know, below what their maximum is, and that's how it should always be. But if you come and look over here at the air handlers, so we have 1, 3, and 5, 2, 4, and 6. There's 3 air handlers on every condensing unit that's on the roof right now. And 2 of them are off. And how can you tell 2 of them are off? Well, right here is the expansion valve. And you can see the expansion valve is at 40, which is basically closed, almost closed. It's just, that's its bare minimum, 40. So it just pisses a little bit through there all the time. Not enough to do any work. The other one is at 490. So this one is working off of this one system with only this one compressor working. On the other system over here, if you look up, you see the expansion valve. This one's feeding hard on this side. The other 2 are off. So you may have an old school technician who goes, you know what, I'm looking for the subcooling coming out of the evaporator, what the temperature is coming out, and these units, they feel a little warm, man. And these 2 units over here, they feel a little warm. This system is low on refrigerant. That's why, you know, it's not operating right. And if you went inside and put your hands up here, you may feel a few degrees difference because these are working so low and this one's pumping out a lot because the expansion valve it's a dwell, it's a duty cycle. Just like a fuel, if you're an automotive guy, this is just like a dwell on a fuel injector. And if you're back from the old Quadrajet days, back in the first throttle bodies, and you had the 2 big fuel injectors onto that first throttle body, remember those old days? And you'd put your dwell meter on there, or you put your oscilloscope and you see that big old square wave. Exact same thing. These are just like, think of the dwell time. And that's how it's a stepper, feeding and opening. Think of it that way. So if you came by and put your hands on these, an old time guy would go, oh shit man, this system's low. I better go up on the roof and break out a can and pump some refrigerant in there. This is why these guys need to be educated or eliminated. And this is how one of my systems got a burnt up compressor on it, because of one of those old time refrigeration guys did the beer can cold thing and thought it wasn't right and pumped another like 27 pounds into a system right into the compressor. And guess what happened? Okay, so this is why you need the software. The software, everything you think your gauges could tell you, and I use the word think because your gauges ain't going to tell you shit on these systems. Everything, the pressure switchers, the transducers, the points where they get their superheat and subcooling to figure out what compressors to turn on and off, what flow rate to wind up the compressors, what air handlers to turn on and off, is all figured out by software. Your human mind and hand cannot compensate for what it is or is not doing under the ambient load conditions that you're trying to use your normal thinking of a straight heat pump or a mini split, 1-to-1 mini split. Some guys think they could go, they put their hand on it, it's not cool enough, so we need to pump some more refrigerant on it. Well, you better take into account of the ambient situation it's under, and you better know enough to put the system into its test mode to totally take the computer out of the loop and then do your hands-on beer can cold kind of thing if you were going to think of doing that with a mini split. Read the book and find out how it operates before just throwing your hand on it and squirting refrigerant in. Because here's a situation where up on top of this room here, there's 6 air handlers. And out of the 6 air handlers, only 2 are pulling the load right now. And so anybody who would go by would say, hey, there's a problem, but there is no problem. This is what and how it should exactly operate. And then other times, once I already did a video on this, there's like a couple of videos back, where one whole side will die and it'll split it up because two of these air handlers are in the front of the room, one of these air handlers are in the back of the room. So if you picture this is the shape of the room. Right in the middle, an air handler feeds, and on the other side, the two slightly smaller air handlers, they feed off to the corners. So you have one larger capacity and two smaller capacities, kind of evening it out. And then on the other system, it's the exact opposite. You have two smaller on the corner here and the one bigger feeding the center. On this system, that's on the other heat recovery system on the roof. And so it's constantly rotating the air handlers based on the sensors that are picking up the temperature. You see here, 75 degrees, 76, 76, 77, 77, 77. It's reading the temperatures coming out, and it's using its own logic on what air handlers it's going to choose, and it keeps learning until it could start dropping and turning on and off the right air handlers for the load that is in the room at that moment. And this is a dynamic load that changes every now and then while they do a different process. They turn things down, they turn things up on load. Sometimes they have a huge latent load inside there when they're doing a wash or a spraying, where they're spraying tons of water in the air through a process that puts a lot of water in the air, and all of a sudden there's a massive latent load in between certain cleaning processes. So that will all be picked up by the sensors, and it'll kick on and off like you see right here. The compressor went off while I was talking. It's now only running on this system, and it's just cruising. Basically it's highway, you're going straight down the highway, your pedals just barely touching, and that's what it is. And if you went up on the roof and you grabbed the return line, you would see it's not as cold as you think it should be. And this is where all the old time guys get it wrong, and the first thing they want to do is grab a big old jug of 410 and start squirting it in there until they could get some coldness. There is nothing wrong with the way they operate. That's exactly how they operate, and you can tell that, see with the temperature, by everything's here has all the temperature. You don't have to put no field piece clamps on it, no testo clamps or anything, because everywhere where the temperature should be right, they have sensors. Automobiles are the exact same way now. This system has come to cars, and so the guys who are in automotive are going to have to learn that using your gauges is going to be something that it'll be history. You know, 15-20 years from now, some young guy will be going, oh wow, I heard you guys used to use gauges. How did you hook them up? What did you do with them? How'd they work? How'd gauges work? Because gauges are going to be a thing of the past. So you guys that are using gauges, including myself, on cars, gauges will be a thing of the past. That's all I gotta say. And to show you the load, here's the room load, and those sensors, remember I was telling you the air handlers and the sensors. So where you see 76, 77, 77, 77, 76, 77, that's what was over there right now. And that's the sensor that's in the air handler telling you what the room is being made up. And it's actually juggling between 1, 2, and 3 air handlers right now. It doesn't even need them on right now, but there is a massive load in the room. And as the weeks go on and the load gets higher, because their call for temperature is going to go all the way down to 60 degrees, and when they call for 60 degrees, that's when the system's going to have to do some work, and you'll see all 4 compressors come on. That's about it for now, and I'll see you guys later. And let's see, anything else around? I'm not going to go into any details now. Details on this will come at a later time, and maybe I'll dwell on like 1 or 2 sensors and what they do and how they react to things, because there's just too much to just start pointing out things and going over. All right, see you guys later.